Welcome viewers. Now let's see some of the case studies for the large scale social networks or the graphs with the help of network science techniques. But before we go in, let's see why we want to take up social network at the case study. So as on the screen you can see that the people who are on the online social network portals or different social media portals, they are just kind of increasing exponentially, right? So by the end of this year there could be like more than 4 billion people, much more than 4.5 billion people on the social network profiles. So there are different ways through which these people are interacting the social network platforms. So there could be several social network platforms like YouTube, Instagram, Twitter X, and LinkedIn, and so many more, right? So sometimes they are doing it for promoting their own brand or sharing the contents or maybe diffusing a particular idea or maybe just interacting something and get some feedback on their concepts. Overall also you can see that if you see the nations at wide, the people are increasing like anything on the social media portal, because of course it's a very seamless way of getting connected to all other people in the world irrespective of the distance apart. Now that we know that what is the relevance of the social network or the online social media, these are the two terms that we are using as of now interchangeably. Let's now understand the taxonomy of the social network. So now social network could be online or it could be offline. So it always doesn't mean that the social network has to be on the online platforms. It could be anywhere where the people are interacting socially and forming some networks. So it could be offline in form of classrooms or meetings in departments or organization at large, where the in-person meetings are happening, where the internetworking computer technologies, or you can say the networking technology, the hardware network technology are not required. And then there are the social network where all these things are needed. The bandwidth is needed, the network connection is needed, the power is needed. So these are the two things where we are more interested to probe into, because these are the networks that are very large, and it has different types of scalability. So it could be a small scale or it could be a large scale social media network. So it depends that what is the community size, what is the number of people who are participating, and you can say that what are the different types of networks and the associated tools and APIs in the system. Now let's see what the social media, the online social media particularly, it requires. It requires the large scale information archives, because when the network is so large, you have to find some way of storing the information. So mostly the archives are on the cloud. And once the data is stored, we also need to have some intelligent techniques, the data mining techniques, the data science techniques, the AI techniques, and we also would like to have the visualization of how these nodes are connected, how the connectivity is forming, and on what context this connectivity is evolving. And altogether, when there are processing, visualization, storage, retrieving, so all these things, they make up the knowledge management system for the online social networks. So when it comes to the social network, or you can say how the people are interacting with each other, there are several things that comes into play, like the social network sites, what kind of sites are being used, and we have to carefully use the sites because we know that the power of social media is very immense. So its use and misuse has the power of creation and destruction. So it's very rightly said. So how the information is propagating, the as computer scientists we have to be very careful of devising the protocols and the algorithms to study, to track down the usage and the misusage of the particular technology. Now let's see some of the open research areas in this particular context. The first one is graph data analysis. So there are like concepts called the knowledge graphs which are evolving these days, wherein just not one kind of relation is existing, but there are different types of relations existing on the same graph. So this is actually happening in the real world. So for example, if say in a citation network, there is a publication of a content, okay. So there could be a publisher associated with the content who has, who is the owner of that particular, who has written that particular article, and then there could be the publisher who has published the article of the author. Then it could be the case that the author alone has not published. He could be having a number of other people in his or her, networked research community. So there could be peer researchers in his community. So there are so many relations. Who is publishing? Which is the publishing house involved? What kind of article is being published? And then who are the different people who are into that particular research with the author. So author and co-author network, they are also being visualized in the same graph. So how this entire relation between the kind of network, or you can say the citation network is being done, and how the information is being flowing across the connected communities of the researchers, all these things are analyzed using the graph data analytics. So this ultimately is going to help in the content sharing. Next is storage and visualization. So as we already just discussed, that it's very important to have large scale information archives, because we have large scale data in form of not only the person, the profile, the posts, but also in form of the connectivity, that who all are connected at this particular time, and maybe in the future those connections can get missing. There could be new links, some links could get disrupted, some links could get newly formed. So a lot of pre-processing and data transformation tasks are required. So there are different data science and network science pre-processing techniques that are required to analyze all these things. So how the large scale graph is to be formed, how the knowledge management system can be helpful to understand the layout, the representation of these kind of large graphs, so that we can apply at a later stage the machine learning algorithms and take a portion of the connectivity information and help the AI model to get trained and tested and provide us with certain beneficial or crucial information. Now, when we are studying these graphs, there are different ways of acquiring the information. So it could be using through the standard repositories like the GitHub or the standard the Stanford standard repository, the SNAP. There are Kaggle, Open Flights, and the Global Terrorism Database. So many standard repositories are there from where the data can be taken, or you can use the APIs to have the data directly from the real world. So it helps you to get the streaming data sometimes, so that you can work on the real world, real time data. Now let's revisit the 17 SDG goals that we have seen earlier also, and now let's try to map for online social networks how these SDGs, some of these SDGs at least, can be mapped onto. So there is this objective, the SDG 4, quality education. So social network is not just about the the news and the current news that are being propagated, but it is also about different other domains like academics and research. So with the help of network science, we can do sociogram analysis, especially for collaborative learning environment. Also in the organizations, like in companies, bigger companies, they have the requirement of forming the smart teams for meeting their deadlines, for meeting their strategies. So how they are going to put specific people in one team so that they can meet the deadlines. They have almost the same kind of people working in same expertise of the people working in a particular team, or sometimes different people with different expertise are required in a team. So analyzing and formation of this team is very important, which is called the smart teaming. So for this also we need the information of the people who are on the network of this particular organization. Next is the gender participation and neutrality in the organization. So we can also analyze how people of different gender they are participating in the organization, whether there is a demand of gender specific participation or not. So these kind of recommendations can come across through the network science analytics. Then of course we have viral marketing for understanding the socio-economic challenges. If we want to do a brand promotion, then who all are our target audience? And just now we have seen the previous one of our previous lectures that there is something called network diffusion. So for network diffusion, the first stage, which is very important, is the set of triggerers, the triggering nodes who are triggering the or initiating the diffusion process, right? So for brand promotion, who are our triggerers are very important. How to set these triggerers, and should the company approach with some some positive offers or some combos, or how to like propagate the content, their content about the newly launched products and all to the public through these set of triggerers. So identifying the triggering nodes for brand promotion is very important and is one of the important open research area for the commercial end. Then also for peace institutions and these things, for these kind of challenges in SDG, there could be analysis of the online networks to prevent crime epidemics and the mob related violence. So that the places are connected through transportation network. Okay, so we can analyze these networks and we can track down if there are some kind of crime epidemics or some kind of violence going on, and which are the getting the hotspots for these. So what can be done to prevent? I mean, like since it's a network, whether the the people who can stop such things, like the police network, how they can reach in a less amount of time, which is the shortest route to reach and stop these kind of violences. And not just the network of the physical world, but also on the online social networks, there are propagation of fake news and mispropagation, diffusion. So these can also be analyzed and tracked down so that containment strategies can be built in for preventing such crimes over the internet. And we have also just seen that there is a GTD data set, the global terrorism data set. So if we are just analyzing these kind of data sets, we can know that which of these nodes, where the nodes will be the crime spreaders, how to analyze that which of them are the black spots in the network. So these kind of research are possible for SDG 16. Then for smart cities and all, we can see that how transportation network again can be helpful to understand the traffic hotspots, and can we deploy some anti-pollution devices at the prominent junctions so as to monitor and to mitigate the congested places with anti-pollution devices, and some traffic policies to handle the congestion and other disastrous situations. Now, applications that we can see at large in this context, they include the community detection, the link prediction, the information diffusion, social balancing. So widely, these are some of the topics that we can see through this case studies of SDG goals. So community detection is again very important, that which are the weakly and the strongly connected communities, and what is the scenario of link prediction. So is there a chance that the people will be more connected in the coming nearer future, or the sparse links will be there? And then diffusion, of course, whatever is the underlying community structure, how the information is going to diffuse. Social balancing is a very interesting phenomena, where the each of the links between two nodes are weighted with a positive or a negative sign. If there is a positive weight between two nodes, it means that they are positively strongly connected, and if it is a higher weight on the negative side, then it becomes that they are negatively connected, or you can say the friends and enemy relation. Then there could be like route recommendation, discovering target audiences, analyzing network crimes, unfolding the trends and events, and then finding out the echo chambers in a particular social network community. Is there a need for the containment strategies inside the echo chamber and all? Detecting communities in the influential profiles of the network is again a very important task, because a person, when you are forming the ego network of that person, there are different ways in which you can look into that person. So it could be the family network, it could be the office colleague network, could be the friends network. So different networks are associated with just one node. So how to analyze the community structure of one person involves studying the ego network in conjunction with other people's network, which calls for different types of community algorithms. So the properties that are of interest while we are doing the detection of communities is the first and foremost is the similarity of behavior. What kind of sentimental inclination people are having towards the person of interest for which we are doing the graph data analysis. How is the structural positioning of the different nodes? So can we use the centrality matrices to analyze the influential people in context of the immediate neighborhood, or the bridging criteria, or you can say the positioning of people in the graph of this particular person of interest. Then there is this interesting topic coming up that involves the combination of network science and machine learning. So there's something called node embeddings. So let's understand as given on the graphs on the screen. So you can have the network of people, okay, and each of the people, they have their own attributes. So it's just not one value, okay. So it's a real world entity, which means that the person has, or you can say the person is defined in terms of his likingness, or what is his age, what is his affinity towards maybe a particular kind of brand, or from where he belongs, the location information, and so many other things are associated with each of the person, or in this case they are called the nodes in our network. So each of these nodes have different attributes, and based on those attributes we can apply the distance formula. It could be as simple as the Euclidean distance formula, or Manhattan distance distances, or Chebyshev distances. So with different distance formula we can find out a distance parameter of one profile with the other profile, okay. And all this can be done for a particular person of interest, as we were just discussing in the ego network of a particular person. So now for that person we can have a clustering wherein all those nodes that are at a lesser distance from in that particular profiling, they can be put together in one cluster, and based on that cluster we can see that who are the strongly connected friends for the person and who are not, okay. And we can also keep on applying the link prediction to see that what are the chances of this person to get connected with other person who are maybe not directly connected as of now, but they are in the friends of friends connectivity. So this way we can apply the network science and try to learn what kind of connections could evolve in the near future using machine learning. Or if we want to label them, label the other people in the network of a ego network of a particular person, that who are the weakly connected friends and who are the strongly connected friends. So this kind of classification and prediction, time series prediction, that is with the time, with the evolving time, which connections are going to get even stronger. So social balancing phenomena can be very significantly addressed with the help of network science and machine learning. Now comes the knowledge graph that we have seen, we have been discussing earlier also, that in the same graph we can have the different information, different piece of information. So if you are talking about the disease network, it could be the disease caused by what kind of genes and all different protein structures and all, and then again what is the symptom associated with that particular disease, and what is the cure associated with the disease, what are the different medicines associated with the disease. So here we are talking about the nature of the disease, the curability of the disease, the spreading ability of the disease, all together in a single graph. So it could be seen from the perspective of not only a disease graph, but also could be a author co-author network or a knowledge network in an organization, right. Then studying the influential communities of the LinkedIn users, that how the LinkedIn users are connected with each other, because LinkedIn profiles are very important, and they help to analyze the people, how they are connected, and who all are more influential with respect to the other nodes in the network. So we can simply go on applying the centrality measures and to see the influentiality of the people in the network. So there could be who are the hubs of the information in the network, and who may be designated as the ambassadors of the people in the network. So even from the Kaggle also you can have data from the data with respect to the LinkedIn, with respect to Twitter, with respect to YouTube users, and you can have an idea of how you can address, you can formulate the problems and you can address these problems using the network science solutions. Then there is online retail marketing. So in retail marketing also, there are this usage of social media at large. They also try to track the website traffic, how and which are the pages in the online social network, or you can say in their online websites where the people are most interested. Maybe for a particular category of things that the company is offering, people are more interested than the comparative to the other products. So they can strategize their how to the sale and the purchase can reflect. So they can offer different combos time to time, different offers, or take the feedbacks and analyze them so that they can cater to the target audience in a better way. Then different types of other insights can also be drawn, like how to maximize the revenue, how to reach the audience in a wider context so that they can create brand awareness for the customers. Then there are online shopping portals, like this was data taken from Kaggle across the different users, and it was tried to find out the loyalty, like how the for the given data set, how the people are showing their purchasing behavior across the different shopping portals. So these studies are all data centric. So whatever data you can get from the public portals, could be GitHub or Kaggle or any other legitimate sites, you can do the processing, the pre-processing and some data mining, and then apply the network science techniques once the network is formed. So this is one more example of the transportation network where you can see that how the network hotspots are found, and maybe you can discover the critical nodes and which are the nodes that are acting bottleneck, and many more such options. And using the GTD data set, you can find out the black spots and you can highlight them to see that which are the nodes that are having more connectivity. Okay. So there are many more such case studies that you can explore using the data repositories that are shown on screen. So these are the different repositories that you can go through, and some of the programming platforms and tools that you can use, and some of the reference of the API tools and programming libraries, particularly Python libraries that you can refer to, and some online book materials which are very much useful for network science study. And these are the references to more explorative work if you're interested. So many thanks for listening to the lecture. I hope it was very useful for you. Thank you.